So far, we have generally completed the introduction to AMD GPU internals. Let's have a summary of the whole section. At the beginning, we talk about AMD GPU families. We introduce the different type of chips that includes GFX 908 or 803. We talk about different GPU generations, that is GFX 9, GFX 10. There are also some commercial names that you should be able to map those commercial names back to the chips and GPU generations. Those commercial names can include Vega or Navi GPUs. Now our second video introduced the AMD GPU assembly languages. We use the CDNA assembly language as an example. So AMD GPU assembly has differences between vector and scalar instructions, and the memory read and write sequence synchronization is one of the most important design for AMD GPU assembly languages. And we also introduced the predicated execution, how your GPU program handles thread divergence. In the third video, we talk about block dispatching. We talk about the wavefront slots. We talk about the scalar register and vector register resources, and also LDS resources. We talk about in what case one wavefront and one block can be executed in one compute unit. We also introduced that blocks are not executed at the same time on your compute units, so global synchronization or kernel level synchronization is not likely to be possible. You have to start a new kernel to perform global synchronization. In the fourth video, we introduced the compute unit architecture. We talked about the fetch arbiter, the issue arbiter, and different execution unit, the branch unit, scalar unit, vector memory unit, SIMD unit, and LDS unit. Next, we talk about the details about SIMD unit, what are the lanes, and how the instruction issuer works together with the SIMD unit to achieve the maximum throughput. We also calculate the GPU computing capability and knowing how this SIMD unit is powering the whole AMD GPU's computing power. And finally, we talk about the memory hierarchy. We talk about what is memory coalescing, how memory coalescing can impact performance. We talk about the core side caches and memory side caches and the GPU cache coherency issues. So far, you should have a good understanding about AMD GPU internals. And in the next video, we're going to introduce some ROCm tools. And using those tools and the knowledge about the GPU architecture, you should be able to tune your GPU program to achieve higher performance.